Hi everyone. In this video, we will solve the basic question, that is the minimum and the maximum element in the array. So what we are given just an array and we have to find the minimum and the maximum element from that array. So if this is the array given to us, we have to find the minimum element, that is in this array the minimum is 1 and the maximum is 1000. Okay, we have to return it. So what is the naive approach to solve this problem? It is a basic problem. So what is a naive approach to solve this problem? So what we can do, we can sort the array. We simply sort the array. The first element is our minimum. The last element is our maximum. Okay. We sort the array in the ascending order. The first element will be our minimum element. And the last element will be our maximum element. It is as simple as that. So what is the time complexity in this case? The time complexity is n log n, where n is the size of the array. Okay, so n log n is the time complexity required to sort the array. Okay, and the space complexity will be constant because we are not using any space, any auxiliary space, but the time complexity is quite unsatisfactory. So what we try to approach this question in a less time complexity. Okay, so what can we do? What we can do, we can traverse the array. A linear traversal we can perform on this array, and we will maintain two variables that contain the current maximum and the current minimum. Okay, and when we find an element that is greater than our current maximum, we will update our current maximum, and whenever we find the minimum element, the element that is minimum to our current minimum, we will update our minimum value. Okay, so what I am saying, we loop over or traverse the array from left to right. We'll traverse the whole array if our current element is greater than the maximum current maximum. We're gonna update our maximum. Okay, we're gonna update our current maximum with the current element, because the current element is the maximum till current point. If the current element, that is a of I, is smaller than the current minimum, that particularly means that this current element is the minimum element till this point. Okay, so we'll update our minimum as the current element, and we perform this for all the elements in the array, and at last we will be having our maximum of the array and the minimum of the array. Okay, so this is a simple approach that requires a time complexity of order of n, where n is the size of the array. Okay, and we does not requires any space complexity. Okay, so there is one more optimized approach. Okay, more optimized approach that reduces the number of comparisons. Okay, so what we are doing, we are comparing if the current element is greater than the current maximum. If the current element is greater than the current maximum, then it should not be smaller than the minimum. You have to understand it. If the current element is greater than the maximum, then we cannot find the minimum in it, because it is greater than the maximum now, current maximum. So we cannot find a minimum element. So at this condition, we only find the maximum, we update the maximum. Okay, we're going to update our maximum here if the current element become greater than the current maximum. Else, if this is not the case, what we will do, we'll check if the current element is less than the current minimum till this point. If the current element is minimum than then the minimum till this point, then we'll update the minimum. Okay, so this will reduce the number of checks, as if the element is greater than the maximum, then we should not check for minimum. Okay, because we are checking here, these if condition will be executed for every iteration. There are two checks, so basically there are two n checks when we are using this approach. But when we are using this approach, there are only at max there can be order of n, because either this condition will satisfy or either this. Okay, so this is a most optimal approach that requires a time complexity of order of n, and also the number of checks are n. Here the number of checks are 2n, because for the maximum we are checking one time, and for the minimum we are checking another time. Okay, here we are checking if the current element is greater than the maximum this till this point. Then we just update the maximum, and if this condition does not satisfy, we then check for the minimum. Okay, so this will reduce our time complexity. So we can also check for it. uh, we can also check a test case for it. So at the starting we have the maximum and the minimum as 3 as the first element. Then we move to the next position. The next position, we gonna check if the current element is greater than the maximum. No, 2 is not greater than the maximum. So we move to the else condition. So we'll move to this condition. If the current element is smaller than the minimum is 3. Yes, we're gonna update the minimum as 2, and the maximum will be 3. We move to the next element. If the current element is greater than the maximum, no it is not, then again we move to the else part. We again check if the current element is smaller than the minimum element. Yes it is, so we're going to update again our minimum as 1. We move to the next element. If this element is greater than the maximum, yes it is, we're going to update just our maximum. And move to the next element. We do not check for the minimum element, because if the current element is greater than the maximum till this point, then it should not be minimum. Okay, it cannot be minimum. Okay, so we move to the next element. Okay, so it is greater than the current max, so we're gonna update it. We again move to the next element, because we are not checking for the minimum. We again move to the next element. We again check if the current element is greater than the maximum till this point. No it is not, so we move to the else part. If the current element is smaller than the current minimum, no it is not, so our maximum in this array is 1000 and minimum is 1. So this is the most optimal approach that requires a time complexity of order of n and a space complexity of order of 1, that is the constant space, but also have but also check for the conditions at max n times. Okay, so this is a simpler question. Okay, if you have any doubt, please feel free to ask. Okay, bye.